Okay, so have you started the stream? You just go back. Okay, okay. You can see now what is written. Yeah, yeah, please come. Okay, so now you are live. Okay, now see what is written. Read what is written on the board. Okay, so how is it? Is it working now? Okay, listening the WhatsApp sound and just looking at the YouTube. Is it okay? Yeah, yeah. So that will be better. Means after listening me, you will be ready to reply. Understanding? No. And when you will see, you will reply fast. Okay. Okay. So we will try one class or two class like this. If it will be normal, if you will be comfortable, you will continue. Fine. Okay. So number system. In the early exercises, we had missed one thing: how to find rational numbers between two given rational numbers. Okay. This thing we will see. After that, we will see some laws of exponents and how to work on that. Okay. So today we will be focusing on this, how to find rational numbers between given two rational numbers, and the second we will see the laws of exponents, and the last exercise works. Okay. Yes. Okay. Hmm. Okay. Okay, so no problem. Okay, but little half an hour, 1 hour you can spend. No, today half an hour, 1 hour. Yeah, homework only. I'm telling that in the evening, 1 hour or 45 minutes or 50 minutes like that you can spend. No, no. Okay, then no problem. Okay, no problem. We'll see. So see how to find. See if the same day you will not practice. No, after 3 days you will forget everything. That is the problem. Okay, so if little you will spend time today and just you will revise what you have studied and few questions you will solve, it will be okay, good enough. Okay. Because see 3 days gap, no, then you will miss the things. How to find, because everything is new for you. Whatever we are studying here is new. Okay, so if maths we are learning something new, and if you will not practice, everything will be erased. Okay, it won't go in permanent memory. It will be from temporary memory. It will go away out of brain. Okay, so see here how to find rational numbers between two given rational numbers. Rational number is quite clear, that any number in the form of p by q, in which p and q both integers and q not equal to 0, that come under the category of rational number, and q not equal to 0. Fine. So how to find? So let us take some rational numbers. Let us take 2 by 3 and 3 by 5. Suppose, okay. So I took two rational numbers here. Are these both rational numbers? Yes. Fine. So we took these two rational numbers, and between these two rational numbers we have to find what? Between these two rational numbers we have to find some rational numbers. Let us take find five rational numbers between, find, first question, find 5 rational numbers between 2 by 3 and 3 by 5. Okay, it's asking that between these two rational numbers, find 5 rational numbers. So one question from my side, how many rational numbers we can find between these two rational numbers? How many rational numbers? Total of how many rational numbers we can find? Yes, you know this. Okay, good then. So infinite number of rational numbers you can find. Okay, where do those infinite rational numbers actually lie? Where do they lie? What is their home? They lie somewhere, no? Where do they lie? All those infinite rational numbers, where do they lie? Where? 2 by 3, where does 2 by 3 lie? Where does it lie? On the number line, man. On the number line. Somewhere 2 by 3, okay? And then somewhere 3 by 5. Understanding? Somewhere they lie. And each and every point on the real number line, there exists a real number. Real number means either it can be rational or irrational. There exists a rational or irrational number each and every point. Okay, each and every point. So if I'll ask you between, if it is a line segment, here is one point, here is one point, how many points are there between these 2 points? How many points are possible? How many points are there between these 2 points? Infinite. Infinite. Okay? A line itself is made up of infinite number of points. Okay? Are you here, only no man? Hey, come on, man. Okay, so how many rational numbers we can find? Infinite, because there are infinite number of points between any given 2 points on the number line. Clear? Now, the next question is that you told how to find 5 rational numbers, you told you will find. Okay, find. Say what to do. Say what I should do. What you're telling, man? Make the given fractions like fractions. Hey, so many hundred you are telling. What, man? See, what is written? Make the given fraction like fraction. The first step is step 1. Step 1. What is the step? Make the given fractions. Make the given fractions like fraction. Like fraction means no, those fractions which have the same denominator, they are called as like fractions. Okay, those fractions with the same denominator are known as like fractions. Okay, so make the given fractions like fractions, the first step. Let us make it. How to make the like fractions? There is a way. First take the LCM. LCM of both. How to do that? How to do that? Take LCM of both the denominators. Okay, take the LCM of both the denominators. Let us take how much? 3 5s are 15. How much LCM? 15, no. 15. Now tell me, in 2 by 3, what I should multiply so that it become 15? 3 denominator. How to make 3? Now we have to make the denominators equal to LCM. So 3, how to make 3 15? Okay, yes. Yes, how to make the denominator equal to the LCM? Yes. So 3 into 5. No, 5. So shall I write up also 5 or not? Why? Why should I multiply up and down both 5? So as not to make any change in 2 by 3. So as not to change the value of 2 by 3. 2 by 3 has to be 2 by 3 only. Okay. So we had studied no that multiplying up and down with the same value does not make any difference in the actual fraction. That's what why we are multiplying up and down both. So how much we got? Up 10, down 15. Okay. Next, this work done. Next, for next what we will do? 3 by 5 is there. With what we should multiply to make the denominator equal to LCM, that is 15. 3 by 3, no? 9 by 15, is it clear? So see, the first step I did. Given fraction like fractions, how to do that? Take LCM of both the denominators. I took the LCM, it became 15. Okay, LCM is 15. Second, make denominators equal to LCM. I made the denominators equal to LCM. No? LCM of 3 and 5 is equal to 15. Fine. So I took here. Now, what are the given fractions we got? 10 by 15 and 9 by 15. No? Next, what is step? Step 1. This was step 1. Step 2. What is step 2? Multiply both the fractions. Multiply both the fractions with what? Bigger number. So one more than the one. No, not so big, man. One more than the required number of rationals being asked. Rational numbers being asked between the given. How many rational number is being asked here? How many? 5. No, we have to get 5. So what to do? Multiply this with 5 plus 1, that is 6. So multiply them further with 6, up and down both. Okay. So what is the next step? Multiply the numerator and denominator of both the fractions with a number greater than the required number of rational numbers being asked. Okay, what to do? After, yes, first understand. Multiply the numerator and denominator of both the fractions with a value what? With a value number greater than the required number of rationals being asked. How many rational numbers being asked? 5. So multiply it with one more than that, that is 6 up and down both. Into 6 up and down both. Multiplied? So how much we will get? Tell me. 10 6 60. And 15 6 how much? 90. And 54 by 90 we got. Okay. See what the two fractions we got. What is this 60 by 90? It is 2 by 3. What is this 60 by 90? It is nothing but 2 by 3. And what is this 54 by 90? It is nothing but 3 by 5. We have multiplied again both numerator and denominator so as not to bring any change in its value. The value is still remains same, 2 by 3. The value still remains same, 3 by 5. Is it clear now? Now, now 5 rational numbers between 54 by 90 and 60 by 90 are how much? 54 to 60 we have to go. 55 by 60. This is the answer, okay? So 5 rational numbers between this and this. What was this? 54 by 60, 54 by 90, it was 3 by 5. And what was this? It was 2 by 3. Understood? So we got this. Any problem in understanding? So one more time. What we did very first thing, we wrote the fractions between which we have to find, okay? Then we made them like fractions by taking the denominators LCM and making the denominators equal to the LCM. Okay, we did here the two. After that, what we did? We multiply both up and down of both the fractions with a number greater than the required number of rational numbers being asked. And after that, we just got the values. So these answers may vary from person to person. Okay. So don't panic. Yes, don't panic, because since we have infinite number of rational numbers, so these are only 5 that is being asked, no problem. Other 5 can also be written, okay? So since infinite, so answers may vary, don't worry about it. So just copy it properly. Sorry, what is happening? Which one is dancing? Oh, that, sorry. It got little touched by my hand, yes. Okay. Okay. So you have fully reduced the YouTube sound? Okay. So did you means in this explanation, did you face any problem with that YouTube video and this sound, WhatsApp sound? So clear? No, we can continue like this. See what happens with this. No, what benefit I get, that when you listen to my words and when you see, before that only you just try to answer, means understanding. No, it does not take time. So after listening my words, when you are watching there, you are trying to answer at that time for any question, or you are trying to be attentive. Okay. So like that it's working more better. So see, the ninth what you are studying now, not only for ninth, be careful, okay? It's also for 10th. So all the basics, whatever the things are required, I am giving everything, okay? With if one topic is there, whatever the things are related, I am giving each and everything, okay? Previous, all the things I am collecting together and giving. So please don't overlook all those other things also, okay? Take care of everything. try to understand each and everything, focus properly. Okay, what will happen? You will be, by the end of the ninth, you will be strong enough to catch the concept of 10th easily. Okay. So please be attentive every time you study. Don't think, okay, this is ninth, we will study anyhow, somehow, and then 10th you will focus. No, okay. And from ninth standard itself, you start trying getting 90 plus. Okay, because nothing less I am giving. Okay, nothing less. Okay. So if you will work properly and the same day if you will finish the things, it will be more better. Okay. So try to get at least 90 plus, and hopefully school will start, means offline classes like that, normal classes may, it may start from November like that. Okay, hopefully. Yes, yes. Because in school, yeah, in school there are lots of students, so whatever the online classes is being conducted of from the school side, the thing is that so many students are there. Okay, and how teachers are, how are you getting your online school class like this only on board teacher is explaining? Okay, okay, and not on board. Okay, okay. Okay, no problem. You just continue and focus properly. No, that will be enough. Okay, whatever you are starting, we have started. No, this will be enough for your portions. Okay, so please be attentive and don't underestimate, overlook these classes. Yeah, yeah. For this also, we'll do the exercise. Don't think that I will just skip the exercise. We will touch. Let me cover everything in this, and then we will start from 1.1 to 1.6. Nothing is there. Okay, everything we have done. Hmm. We will study exercise also, man. Don't think I will leave. Different type of finding methods. Yeah, we have. No, 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 not only method. We have a lot of. We have. Okay. Have you copied this? Have you copied this? Okay, finished. Now see what we have. Another one. For 2 by 3, let me erase this and it. See, my intention is not only to cover the portion. Please focus, okay? Okay, so please be cooperative, no, and you will never regret for this, okay? But you have to be honest from your side, okay? Okay, fine. So see here, 2 by 3 and 3 by 5, okay? Now, there is another way what, that let us find exact the middle number lying between these two, okay? So let us leave it. Let us, yeah, let us leave it like this. Let us see a smaller number, the whole number like that. For example, 4 and 8. Okay, 4 and 8. We have two rational numbers. Are these two rational numbers or not? Yes, they are two rational numbers. Okay. So if we want to find some rational numbers between this 4 and 8, we can use this all method, no problem, all the steps. How? By making 4 by 1, 4 by 1, we got the fraction. Okay. Then step 1 is to make the like fractions. They have already the denominator same, so they are already like fractions. They are already like fractions. So suppose if I want to get how many? 5. 5 rational numbers between them. So what to do? Multiply up and down both with, means step 1 is already done here already. Okay. Step 2 only we have to do. So multiply both up and down by 6. Understanding? If we need to find 5 rational numbers, then how much? 4 6 are 24. 24 by 6 here, 48 by 6. Okay, what I told. So step 1 is already done. No, like fractions, their denominators are already same. So step 2, multiply with some value greater than the required number of rational numbers being asked. I multiplied 6 and 6 up and down both. I got this value. Okay. Now how to find the rational numbers between this denominator same? 25 by 6, 26 by 6, dot till 47 by 6 we can write or not? So many rational numbers we can write. So these all are rational numbers between 4 and 8. Is it clear? This if whole number is given, we can directly apply that. But what I want to tell you, see here. Actually, you asked me another. See, 4 and 8 is there. No. What is another way? You just add both and divide by 2. 4 plus 8 add and then divide by 2. Okay. So how much? Six. Okay. So 6 is lying exactly in between 4 and 6. 6 is exact middle value between 4 and 8. Sorry, 4 and 8. 6 is exactly middle value between 4 and 8. Understanding? Further, what we can do? We can take again these two, add and divide by 2. We will get exactly middle value of 4 and 6, between 4 and 6. How? 4 plus 6 by 2. How much? 6 plus 14 by 2, that is 5. So we got exact middle value between 4 and 6, that is 5. Okay. Next, what we can do? Take 6 and 8, add them and divide by 2. 6 plus 8, 14. 14 by 2, 7. We got again a middle value between 6 and 8, that is 7. Are you here, man? So are you understanding? Are you understanding? Okay. So what if this method says that go on finding the exact middle value between any two given numbers. How? Add the two numbers, given two numbers, and divide it by 2. No. Now suppose I want more numbers in between. So let us take 4 and 5. Let us take 4 and 5. So 4 plus 5 by 2. How much? 9 by 2. So do you know where does 9 by 2 lie? 9 by 2 will lie exactly between 4 and 5. And that is also a rational number. So 4 and 5, 9 by 2. Understanding? If further you want to get some numbers between 5 and 6 exactly middle, what to do? 5 plus 6 by 2. 11 by 2. 11 by 2 will exactly lie between 5 and 6. Exactly in between it will lie. Now take 6 and 7 and just find. So 6 plus 7, how much? 13. 13 by 2. 13 by 2 will lie here. Add both. 7, 7, 14, 15. 15 by 2 will lie here. Understanding? And go on taking any two numbers, add them, divide by 2, you will get the middle rational number. So like this also we can find so many rational numbers, okay? As many as we want. Okay, so see, between 4 and 5 we got how much? 9 by 2, isn't it? Now if I want more between 4 and 9 by 2, what to do? Let us take these two. So 4 by 1 plus 9 by 2. No, the whole divided by 2. We can solve this. We will get another rational number between 4 and 9 by 2. So let us add this. Let us add this. How much? LCM. 2 into 1, LCM 2. Then 1 into 2 is 2, so 2 4 is 8. plus 9. Okay, the whole divided by 2 as it is. Then how much? 9 plus 8? 17. 17 by 2, the whole divided by 2. Okay, so how to solve this? This 2 means what? 2 by 1? No. In the numerator itself, we have numerator by denominator fraction 17 by 2. In the denominator, we have 2 by 1. So how to divide this, how to solve this? If we have some numbers like a by b, the whole divided by c by d, how to deal it with? A by b we will write first, and then this division we will change the sign to multiplication, and this c by d will reciprocate. It will become d by c. Okay, this is the way to solve. You know this? A by b into d by c, d by c. It will reciprocate and get multiplied with the numerator. Isn't it? So see here. And it will reciprocate also. It's reciprocating. It's c by d, no? Here it is becoming d by c here. So here it will be 17 by 2 into 1 by 2. Understanding? So it's becoming 17 by 4. So what is this 17 by 4? Okay. So this is 17 by 4. So what is 17 by 4? 17 by 4 is the number between 4 and this. Understanding? Means 17 by 2 will lie here and then 4. Between 4 and 9 by 2 there is a rational number that we have found, 17 by 4. Understood now how to find that? I mean, add and divide by 2. So I added and divided by 2. How to solve this I showed you. Okay, how to solve this. So this is another way. Okay. There are more ways to first convert into decimal and then write. So don't get confused in that so much. Okay. These two methods are enough for right now. Okay. Right now these two methods are enough. When it will be required further, I will teach. Okay. Okay. So just copy it down fast. Try to understand. Copy it fast. Middle value, yes, and that middle value is also one of the rational numbers. So either you say to find rational number or to find exact middle value. It depends, man. Suppose some cancellation is there, no cancellation like this, 2 or 3. What in writing? It's all mixed. So this side you covered, no? This side you copied, no? Oh, then leave this side. Okay, leave, because there is no steps written. Just understand one thing. What? That we have to add and divide by 2. Okay. What? Oh, this one. Okay. Then fine. This problem solved. Okay, we have studied this. Finished. How to find rational numbers between two given rational numbers. Okay. Yes. The ink has got old actually, so it's taking more force to get clean. Sometimes, man, not always. Okay, one thing. If suppose we have quick revision of that, tell me about the decimal fraction or decimal fraction. How many types and in which it will go? Good. Terminating and non-terminating. Okay. And this is non-terminating. Fine. In the non-terminating we have recurring and non-recurring. Tell me which one will be rational number? This will be rational number? This will be rational number or not? This type of decimal fraction, the terminating decimal fraction, will come under rational number or not? Yes. This type of rational number will come under decimal fraction will come under rational number or not? Recurring will come under rational number or not? It will come. This one? No, it will be irrational. It will come under irrational, okay? It will come under rational. And this will also be rational, okay? Rational, irrational. Now, let us take some example of terminating now. For example, if I write 3.4, what is this? Terminating, it has a stop, no? 3.5, 2.7, okay? 5.2, all these are what? Or even you can take double 3.77, what is this? No, 77, no, it will not. 75, 4.25, anything, okay? Or more. So what all these are terminating? These are the examples of terminating decimal or not? Say something, what happened? Again you started thinking something else, huh? Yes, man? Hey, where are you gone? See, Joshua slept. Hey, where are you gone, man? Where are you? Okay. Can you listen now? Okay. Okay, So see here. So these are the examples of terminating or not? Terminating decimal fraction? Yes. How we understood this? It's understood that after decimal, after certain places of the decimal, it has a stop. Nothing afterwards. It's not like 3.4 like this recurring. No. What does it mean? It will come under this. Means 3.4 recurring means when we will divide some a by b, we don't know what it is. Some a by b, after dividing a by b, we are getting 3.44444444, and it will continue. That's why we wrote here what? 3.4 bar. But since no bar, it means it has a stop. Some fraction p by q, we divided, we got 3.4 and the denominator comes 0. Remainder comes 0 in this case. Means it has a stop, it has terminated. So that's why it is terminating decimal. Okay? Remainder will be coming 0 in terminating fraction. Remainder comes 0. Once the remainder comes 0, division stops, and that comes under the example of terminating decimal fraction. Is it clear? Like this, either a single digit will be repeated or a group of digit will be repeated. 75, suppose. What is this now? Some fraction we had m by n. Some fraction we had m by n. When we divided, we got 3.75. Then again 75, 75, 75, 75, 75, 75, 75. It will be repeated. Okay? One second. Suppose this. This is also one of the recurring. In this case, some L by K we had some fraction we don't know. When we divided, we got 3.7555555555. First time we got 7, after that 5, 5, 5, 5, 5, 5 we are getting in the quotient. This means this. So this also comes under recurring. Is it clear now? So, so repeat what? What is repeating? And these are the quotients. These are the quotients. Understanding? These are the quotients. Yes, not the remainders. And remainder also will get same again and again and again and again same. But that's a different thing. But these are the quotients, not the remainder. Okay? Is it clear? These are the quotients. So terminating and in the non-terminating recurring, understood? No? Now see, non-recurring. Non-recurring, let us say, for example, 2.010010001 dot like this. So what is happening? Not neither a single digit nor group of digits are being repeated here. Every time we are getting a different pattern. Every time we are getting a different pattern after the decimal. So this is an example of non-recurring. See, first time we got 0, 1. Next time we are getting 0, 0, 1. Third time we are getting 0, 0, 0, 1. So pattern is getting different. Here the pattern remains same. Pattern remains same here. 7, 5, 7, 5, 7, 5, 7, 5, 7, 5. Or here 5, 5, 5, 5, 5, 5. Pattern remains same. But here pattern is different. Okay. So this is an example of a non-terminating, non-recurring decimal, and it is what? Irrational actually. Okay. If root 2 value is an irrational, no, root 2 1.414 something will come. We won't get any proper repetition of a particular digit or group of digits repetition. We won't get in this when we will find the value in decimal. Okay. But why I have written all this, to understand that how to convert this 3.4 into our P by Q form. Understanding? No, how to convert this type of terminating into P by Q form, how to convert this type in P by Q form, that we will learn. Okay? Of course now, madam. Class is not yet over, man. Yes, what doubt? Yes. Who? Me. I am 7:30 bathing. Who told you? Oh, example. Yes. Then it depends, no, how dirty I am. Okay. So 15 minutes is enough, man. 15 minutes is enough. Enough. Yes, of course. So he might be playing, or he might be very dirty inside, no? So oh my God, see. Now let us see now something. Oh, great. Okay. Let us study. Fine. Understood now? Now see how to convert this into P by Q form. How to convert the decimal fractions, into P by Q form. How to convert the decimal fractions into P by Q form. Okay, is it clear now? Hmm. So now see, the first one, let us take 3.4, okay? 3.4. So this is the terminating one, we can see and understand this is the terminating one. So how to convert this into fraction? So simple. What to do? Let us write 3.4 as it is, okay? And in the denominator, what we'll do? What we'll do? At the place of the decimal, we will keep 1, okay? At the place of the decimal, we will keep 1, and after that, how many non-zero digits are there? How many significant digits are there? 1. So that many 0 we will put, and we will remove this decimal fraction. That is done. What I told? This was there. Okay. Then at the decimal place, you put 1. After that, how many digits are there? That many zeros. And then remove this. So this 3.4 is nothing but 34 by 10 only. Okay. This 34 is nothing but 3.4 is nothing but 34 by 10. Okay. Now any cancellation can we do? Yes. Even. So 2 5s are 10. 2 5s are 10. And then 2 1s are 2. 2 7s are 14. 17 by 5. So we converted 3.4 as 17 by 5. When we will divide this 17 by 5, we will get 3.4 only. Let us see. 5 3s are 15, 0, no, here 0, here 2. 2 came, then decimal, then 0 here, then 5 4s are 20. 0 0. So what actually this 17 by 5 was the actual rational number p by q form, and this is in the decimal form, decimal expansion 3.4. And since this is rational c, p by q, p and q both integers, q not equal to 0, satisfying the condition, no, and that is why the terminating decimal are considered as rational only. Clear? Now let me put some ink. You tell me for 3.5, come on, for 3.5 and for 5.2, you convert and tell me how much. Hello? Yes, do it. Okay, next. (26 by 5). Okay, let us check it. So 3.5, no. So 3.5 is equal to 3.5 I wrote, and then for decimal I put 1, and then after that how many digits? 1, so 1 that many zeros, and remove the decimal, so it becomes 35 by 10. And then 5 2s are 10, 5 7s are 35, so I got 7 by 2, correct? Now 5.2 is 52 by 10, same thing. Okay, then 2 5s are 10, 2 2s are 4, 2 6s are 12, so 26 by 5. Okay, just like that 27, 2.7 is equal to 27 by 10, no, and it won't go with any, no simplification, further simplification, no. So 27 by 10 only. Okay. For 4.25, tell me. For 4.25, 4.25 is equal to 425 by how much? Fast, by 1 followed by how many zeros? Correct. Now cancellation. 5 it will go. So 5 to the 10, 0, and then 5 8 is a 40, and then 5 5 is 25. 85 by 20. No? 85 by 20. Again further it will go with 5. 5 4 is a 20. 5 1 is 5. 5 7 is 35. No? Then we are getting finally how much? 17 by 4. Okay? Let us divide this 17 by 4. Check. 4 4 is a 16, 1, then decimal, and then 0. So 4 2 is a 8, then 2, and then decimal is already there, so 20. So 4 5 is a 20. So finally we are getting 4.25. So 17 by 4 is nothing but 4.25. Understood how to convert one to another, second to first? Is it easy? No? Not tough? Correct. Shall I rub this? Oh. So we understood how to convert terminating decimal fraction into P by Q form. Now we will see how to convert the non-terminating recurring one into P by Q form. Okay, what are the two actually, P and Q, that after dividing we are getting something like this, like this, like this, that we want to know, and how we will convert we will learn. Okay, fine. So let us start from 3.4 bar. So what we will write, let x is equal to 3.4 bar. Okay, I assumed 3.4 bar as x. Clear? Any doubt? No. This is an equation or not? Can we multiply with some value both sides, LHS and RHS, in a particular equation? Will it make any difference in the equation? Will it change the equation? No, it will not change. For example, see here. 5 is equal to 3 plus 2. Suppose this is an equation or not? Correct equation or not? We know 5 is equal to 5. Correct equation? So I told that can we multiply with some particular value both the sides of LHS and RHS with the same value so as not to make any change in this equation? Yes, we can. Let us multiply it with 2, both sides up and down, into 2. No? So how much it became this side? 2 5s are 10. And what to do with this now? These 2 will go and get multiplied with each of the term inside the bracket or not? We have studied. So how much it will become? 2 3s are 6. And plus